Consider the following example. A random sample of patient records were examined where two variables were recorded: length of stay in days in the hospital and level or percentage of charges covered by insurance. Use this data to determine if length of stay seems to depend upon level of coverage. Notice the table has two variables where percent of bill covered is categorized as less than 25%, between 25% and 49%, between 50% to 75% or 74%, and 75% or more. The lengths of stay is categorized as 5 or less days, between 6 and 10 days, between 11 and 15 days, or over 15 days. The table shows the observed frequencies as the first value in each cell, while the second value is the expected cell count. The test statistic and p-value are given in the following table. The chi-square test statistic is under value, and the p-value is the less than 0.0001 number. Using the output, can you determine that level of coverage and length of stay are dependent variables? Use a 1% level of significance. Begin with stating the hypotheses and the decision rule. The null hypothesis, H sub 0, says length of stay does not depend or is independent of level of coverage. HA says length of stay depends on level of coverage. The decision rule is to reject the null hypothesis H0 if the p-value is less than or equal to 0.01, and that comes from the 1% level of significance. Notice this is valid since a random sample of records was taken and all the expected cell counts were 5 or more, 17.88 all the way up to 7.305. Just be sure to circle or highlight or something your expected cell counts so when you're studying you know what values you were looking at. The test statistic and p-value, you need to locate and display these from the output. So the chi-square test statistic is 40.7 when rounded to the 10th digit, or you can just write the abbreviation in letters CHI-SQ for chi-square equals 40.7. The p-value is less than 0.0001. Since less than 0.0001 is less than 0.01, the decision is to reject the null hypothesis H0. This suggests the pattern of counts in the table, in other words the sample data, is very unusual if the variables are independent. So the p-value indicates the data in this table would happen less than 1 in 10,000 studies of this same manner if the variables were truly independent, as we assume under the null hypothesis. I definitely call that very unusual. At the 0.01 level of significance, there is significant evidence to conclude that length of stay depends on level of insurance coverage. Now look at the sample percentages. For each coverage level, calculate the percentage in each length of stay category. How do these results support the findings of the hypothesis test? This table gives the percentages. How do you interpret these values, and how do your interpretations relate back to the findings from the hypothesis test? Let's look at each grouping. The 5 or less column, you see 15.5% to 38.8%. That's much greater than a 10% difference. So this supports a dependent relationship between level of coverage and length of stay. For the 6 to 10 days column, 24% to 45.1% are very different, more than 10% difference. But notice that 3 of the 4 percentages are very similar in this category. In the 11 to 15 days column, the values go from 9% to 43.3%, again being very different than 10%. And the over 15 days column shows 7.5% to 15.5%, only an 8% different, so not very different. Also in this column, 3 of the 4 percentages are very close to each other. But overall, the percentages in the columns are different, which indicates a dependent relationship between coverage and length of stay. This agrees with or matches the conclusion from the hypothesis test. By now you should realize I will expect 2 big steps with this material. First, you'll complete the test of hypothesis to determine whether the 2 variables are independent. Second, you'll calculate the sample percentages and relate their values, or how different the percentages are, back to the conclusion of the hypothesis test. In other words, if the sample percent values are similar, you expect the hypothesis test to indicate there's not enough or there's insignificant evidence to conclude a dependent relationship. But if the percent values are different, much more than 10% difference, you should have significant evidence of a dependent relationship.